We are covering highway capacity analysis for the FE civil exam, focusing on the core concepts of level of service, peak hour factor, and passenger car equivalence. These topics are found in the Transportation Engineering section of the NCEES FE Reference Handbook. The exam will not require a full highway capacity manual procedure, but it will test your understanding of the key inputs and adjustment factors. Level of service, or LOS, is a qualitative measure that describes operational conditions using a letter grade from A to F. LOS A represents free flow conditions with low volumes and high speeds, while LOS F indicates forced or breakdown flow with stop-and-go conditions. On the exam, you won't be determining LOS from scratch, but you need to understand that it's the ultimate output of a capacity analysis, with density being a key performance measure for freeways. A critical input for capacity analysis is the design flow rate, which is adjusted using the peak hour factor, or PHF. The PHF accounts for the variability of traffic flow within the peak hour. It's calculated by dividing the total hourly volume by 4 times the volume of the peak 15-minute interval within that hour. Let's consider an exam-style problem. If a roadway has a peak hourly volume of 2,000 vehicles and the busiest 15-minute interval saw 600 vehicles, the PHF would be 2,000 divided by the quantity of 4 times 600. This gives us 2,000 divided by 2,400, which equals a PHF of 0.83. A common exam trap is inverting the formula. Remember that the PHF is typically between 0.80 and 0.95 and can never be greater than 1.0. A lower PHF indicates more concentrated or peaky traffic flow. Next, we must account for the mix of vehicles using passenger car equivalents, or PCEs. Heavy vehicles like trucks and buses take up more space and have lower performance capabilities, especially on grades, than passenger cars. The PCE value converts each heavy vehicle into an equivalent number of passenger cars. For instance, on a specific grade, a truck might have a PCE of 2.5. If you have a traffic stream of 1,000 vehicles per hour with 10% trucks, you first separate the vehicle types. You have 900 passenger cars and 100 trucks. To find the equivalent flow rate in passenger cars per hour, you add the 900 cars to the result of 100 trucks multiplied by their PCE of 2.5. This gives you 900 plus 250. For a total equivalent flow rate of 1,150 passenger cars per hour. A frequent mistake is applying the heavy vehicle factor to the entire traffic stream instead of just the heavy vehicles. Finally, remember that the ideal free flow speed is adjusted downward for non-ideal conditions like narrow lane widths, lateral clearances less than 6 feet to an obstruction, and high interchange density. While you won't likely perform the full calculation, you should recognize these as factors that reduce capacity. A good mnemonic to remember the PHF calculation is put the H hourly total on top and 4 times the 15-minute peak at the bottom. This isn't a perfect acronym, but visualizing the fraction can help avoid that common inversion trap. The demand flow rate, VP, found in the handbook incorporates all these factors: the hourly volume V, the PHF, the number of lanes N, and the heavy vehicle adjustment factor, FHV, which is derived from PCEs. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.